Today we will discuss about RNN. Okay. So already you people are aware of so many things. What you are aware of so many things means you are already aware of these NLP topics. How the basic NLP topics already you know. Correct or not? Right? So today we will be dealing with the recurrent neural network. So what is recurrent neural network? Hmm? What is recurrent neural network? So today we will be studying about recurrent neural network. So what is this? See, let us say I have one word. I have one sentence, sorry, not word. So what is this? I have one sentence. So what is this? I love my India. What? So how many words you have here? So 4. So 1, 2, 3, 4. At time t is equal to 1, time t is equal to 2, at time t is equal to 3, time t is equal to 4. Okay, let it be as it is. So now, see, if I write the architecture of my neural network, okay. So if I write the architecture of my neural network, somehow it is going to come like this. Okay. So somehow it is going to come like this. Like say I write the figure, try to observe. See here. See, okay. So now you have input layers. Okay. You have output layers. Xi of t in general. Xi of t, yi dash. So along with that you will be having weights, right? So it will pass through certain function. So this is in general, but okay, this is in general. But if you write the actual architecture somehow like this, I can write. So inside this you have several layers. Okay. So x1 1, I'll write x11. x11 gets multiplied by w. Okay, so here hidden layer x12 gets multiplied by w, x13 input to each. See, this is input layer. So input is coming here. So this is the first hidden layer. Okay, so at the time t is equal to 1, at the time t is equal to 2, time t is equal to 3. Similarly, you have x is equal to x14, same w, same w. Okay, so many number of hidden layers will be there. So finally you will get the output yi of hat. What is this yi of hat? This is the model output. Output from the model. So means this is the model. This is the model. Okay. So you will get this output. So this coming out is yi hat. So what is this? This is one more activation function. Okay. Softmax activation function. So at the time t is equal to 4. So means look at the things. I love my India. So there is a sequence. This is a sequential form of network. Okay. So here, so this is the first hidden layer number 1. So I will call this as W1. What is this? W1. And output coming of the first hidden layer, I will call this as O1. This is the second layer 2. Output will come out of the second layer. I will call this as O2. And I will call this as W dash. What I will call? W dash. Similarly, output coming from hidden layer 3 at time t is equal to 3. That I will call it as O3 W1. So this I will call it as O4 W dash, not 1 dash, W1 and W dash, that's all. For odd even, something like that you can think of. Okay. So here also I will assume a dummy inputs along with x1 W. Some dummy I will consider. This dummy is O0. Even the output is not coming to it, I will consider as a dummy output. O0 and W dash. W dash W1, W dash W1, W1 W dash, something like that. For our understanding, that's all. So what is this? This is a recurrent neural network. So what happens? Used for text processing. Text process. The architecture is something like this. Architecture is something like this. So you have what you have? X11, X12, X13 and X14. So right. So what is this called as? What is this X11 and X12, X13, X44 called as? And for X11, see, same W, same W, same W, same W. So what is this W? W I will call it as a weights assigned for inputs. Weights assigned for inputs. And you have W dash as well as you have W1 here. Coming out of the output, you have W dash and W1. These are called as, what is this? These are called as weights of hidden state. Means you observe, so this is the output and this is the input. So from input, so these are hidden layer number 1, hidden layer number 2, hidden layer number 3, 4, and finally some activation function, then that output will come out. W dash, weight of the hidden state, weights of the hidden state. So this is the hidden state. So what is this? So this is the hidden state. This is the hidden state. So what happens? I am going forward direction. It's a forward, feed forward. What is this? Feed forward network. Okay, so in order to activate, so I will say I will go inside this first layer. In the first layer you will be having several 50 nodes, 50 nodes, even more than or less than, depends. Love will get inside layer number 2, my will get inside. So it depends, it's not that each word there should be one hidden layer. I am just assuming. So what happens here? So it goes there, so it will come out with some kind of output. How the architecture is made? See, in each hidden layer, see, from one node, so from one node to another node. See, this is one node, so you have to pass the information from one node to another node. Simply you will not pass. The nodes should get activated. How the nodes are going to get activated? How it's going to be getting activated? So it's going to get activated only when you pass through activation function. When you pass through activation function. What is the activation function? So in RNN we have activation function ReLU as well as tan hyperbolic. In RNN you cannot pass ReLU or only tan hyperbolic. That is what we use in recurrent neural network in the hidden layers, not at the output. What is hyperbolic? Trigonometric, tan hyperbolic. tan hyperbolic x or ReLU. How it is? ReLU will vary from, the ReLU you already know, it will vary like this. No negative. It will fetch that to 0. Max of, what is this? Max of positive, also max of 0 or negative number. If you have negative number, and if it is going to be subjugated to 0 value. Okay, so if you, this is what the ReLU function. So tan hyperbolic, what is this? -1 to +1. That is how it, I think so. I think I am correct. Tan hyperbolic function very from -1 to +1. Tan hyperbolic. So now, okay. So hidden layers, you have the activation function. What is this? Tan hyperbolic x or ReLU. So and after that, what you will get at the final layer? What you have? We have softmax. Softmax is, or rare cases instead of softmax, you can also use sigmoid activation function. Okay. So what is this sigmoid activation function? So this is used for multi-classification. Softmax used for, sigmoid used for binary classification. Softmax, more than 2 classification, we go with softmax. Also we can also use binary classification, also we can also use softmax function. That is also a type of activation function. So this is how the neural network is going to work. Okay. So how it is going to work? Hidden layers are there, recurrent neural network. So that is how it is going to work. So now let us see. For each layer we will see. Okay. Let us study that for the each layer. So let us say for the output layer 1. Output layer 1. What is this? What is the output coming from layer number? What at time t is equal to 1? This is the hidden layer number 1. Output coming from the hidden layer 1 is O1. So O1 is equal to, I want to calculate it. What is this? What is this? It is dependent on x11 as well as it is dependent on w. So x11 into w plus, already you have dummy O0 w dash. O2 output coming out of second layer is O2. It's a function of what? It is dependent on x12 w multiplied by this w, okay, into plus, what is this input to the output layer? The output coming from the hidden layer 1 will be the input to the hidden layer 2. So O1 w w1, okay. Similarly, what is this output coming from O3? O3 is equal to function of, what is this? x13 is this one, x13 into w plus O2 w dash. Similarly, O4 w dash na, O2 into w dash, O2 into w dash. So function of, similarly x14 into w plus output layer coming out of this O4 is dependent on this one, plus it is dependent on this one. So O3 w. Similarly, same way you will get the output also. Right. So now see, final output yi, output of the model, is summation of all this. Summation of O1 plus O2 plus O3 plus O4 put together, we will get this output yi dash. Correct now? So now, what is this happening here? See, each layer is dependent upon the previous layer. Each output coming from one layer is dependent on the previous layer. So now, okay, that is fine because it's a sequential data, it's a sentence. So each word, so it has to come in from the form of a sentence, one after the other, one after the other. Okay. Now what I have to do? So now if you see, if you observe carefully, observe, what is this? I told you what I have to do. So this is the output from the RNN model. What is Y? Actual output. Actual output. So what is loss? Loss is equal to predicted minus actual. Actual. Predicted minus actual. When you differentiate this loss, what you will do? Differentiate this. Differentiate this loss. What is this? Dou of yi minus y. This is what this is. Instead of yi minus I, what I will write? Dou l loss. With respect to what you are going to differentiate? With respect to weight you are going to differentiate. Okay? You are going to differentiate this with respect to weight. So that is one thing. Also this loss with respect to what you are going to differentiate with respect to output. What is the output of the model? Yi hat. So also you can what you have to differentiate? You have to differentiate with respect to weight. Loss has to be differentiated with respect to weight because you need to update the weight. Loss also has to be differentiated with respect to the output. That also has to be updated. So what I can write? So dou L by dou, what is the output? Y hat. Y I hat. So Y I hat. I can write this Y I hat is dependent on dou Y I hat is dependent on what? This Y I hat is dependent on what? So it is dependent on what?
Sir, wait now. Wait.
So this yi, so look at this guys, this yi, this is dependent on this one weight w dash. This is also dependent on w. Correct? So now what I will do, any one I will take. At that time I will not in. So I will take one dou w. I will take. What is this? Dou. So what is this? Again this dou w, correct or not? So similarly, what I can write, this weight. So now this y hat is again, this is also dependent on, this is also dependent on not only w, this is also dependent on, where is this? Okay, here. This y hat is not only dependent on weights, it also dependent on the output from the fourth layer. Correct or not? Correct or not? So what I can write? So next step I will write, loss is dependent on the output, which is dependent on which is also not only on weight, on the O4 also. And O4 is dependent on O4 output. Say, look at this. I'll say this output, this is the output. Okay, this is the output. O4 output coming from layer number 4. It will come. What is the input to this? W. It is dependent on W. If W is coming, then only output will also will come. You are multiplying some x14 into W. It will go to this hidden layer number 4. Output coming, you will call that as O4. So this is dependent on W. So what I can write? So what is happening? This is dependent on W. So I will write it as dou. Like this you can keep on writing. Right? So what is happening here? So even if you cancel the things, loss is dependent on weights. So this is what is called as differentiation. This is called as differentiation chain rule. Means when it is going to happen? During feed forward. During the forward, when you are moving from one end to another end. I am moving from here to here. See, look at these things. Observe carefully. I am moving from here to here. I am not updating anything. I will initialize the network. What I will do? How we are going to initialize the network? So you have W here, you have W1, you have W dash, W1 and W dash. What is W? Weight of the input network. What is W dash and W1? Weight of the hidden state. So I will consider W is equal to 0.5. W1 and W dash I will consider is equal to 1. W and W dash. So you have the word I love my India. Okay. So I have the word I love my India. So what is this? This is the word. So anyhow, you know already NLP. In NLP, what you know? You know tokenization, lemmatization, stemming, vectorization, work out word quantity. So you do apply one of the techniques, you will find a way to convert this I love my India into what? We will convert this into numbers. First we will convert, because it is a neural network. Neural network, it will not take the word. It passes any language, it is not a machine language. So it is not going to take the word. So it has to be converted into numbers. So by count vectorization, this I love my India, each word is going to be converted into numbers. And number, so these numbers will be fed, because here also ReLU function, tan hyperbolic, inside tan hyperbolic function you will pass I love, can you pass that inside the tan hyperbolic function? You have activation functions are there, not possible. So as a result, we have to do the count vectorization. Now I have explained that, now I am coming to neural network RNN. So what is this happening? So every word is going to be converted into numbers, and as a result, numbers are going to be fed into each hidden layer. So during the forward and these weights will be assumed. At the beginning, weights are going to be assumed. Weights are going to be assumed. This x11, what is this x11? What is the value of x11 here? X11 is the value of for I. What is the x12 value for love? What is this x13 value for mine? What is x14 value for India? Means the vectorized, the India is going to be converted into a sum for some form of number. Correct or not? By so x11 you will get a number. W we have assumed. W1 and W dash, that also we have assumed. My neural network got initialized. These numbers are going to be passed through the activation function in each layer, ReLU and tan hyperbolic function. After passing through each hyper, you also have the formula here also for softmax activation function. So all numbers only. So you will get the output. So during the feed forward, nothing is going to happen.
Screen is not visible there.
I will not share the screen. From when the screen is not visible? Is it visible now? From 7:12.
7:36.
So from 7:12, Shobha, you should have called, na? Screen is not visible. Okay. I will just. I have recorded. Don't worry. I am not going to repeat. Just observe, Shobha. I have recorded. You can watch it. I will upload anyhow in the YouTube. So look at this. What is happening here? So recurrent neural network. So just I will briefly tell for Ignoel and Shobha. I love my India is the word. So you know the concepts of NLP. In NLP, what we will do? We will convert all the words into what we will do? Numbers. How you are going to convert these words into number? Techniques. What are the techniques? Using Genesim and NLTK library, we apply lemmatization, we apply stemming, we remove stop words. After that, we use bag of word model, or we use count word vectorizer model, count vectorization, we do count vectorization, or document to word, or TF-IDF. All these things are the different techniques used for assigning you have to give, each word is there, you have to give some value to that word, weightage has to be given to that. That we will be converting, that is what I is the number one word, that is x11. X11 will go to the first hidden layer. Then love, this is x12, this is x12. This will go to the second hidden layer, this is the second hidden layer. Then my, third one, this is the third hidden layer. So x13. Fourth hidden layer, x14. Okay. So that value I got because already I converted, these words are converted to number. Fine. So then what is left? Weights are left. x11 into w. W means already I have assumed, I have initialized the value for w as 0.5, and you also have, what is this w? Weight of the input network. So this is input, x11 into w, this is the input I am giving. This is the input. So this is xi of t. x1 at time t is equal to 1. xi of t. Okay. So into w. So w I am initializing. Initially all weights are same 0.5 only. All weights are same 0.5 only. And also w dash and w1 also same, I have assumed 1. So you have to initialize the network, you have to make certain assumptions. You have to derive some equation, we will make some assumptions. Same way here also we will make some assumptions. So because we need to initialize the network, when everything will be, now everything will be in the form of number. So 0.5 into x11, so w dash is 1 into dummy output O0. Dummy output O0 will be some initial output, also I will take y, let us assume. So it will be passed through ReLU activation function or tan hyperbolic function in each layer. In each layer it will pass through ReLU activation and tan hyperbolic function in each layer, and output will come from each layer. And at the end you have softmax activation function. Okay. So what is softmax? Softmax is the final output layer of the recurrent neural network. Softmax is the final output layer of the recurrent neural network. And at the end what you will get? yi hat. What is this? Model output coming out of our recurrent neural. This is the predicted output. What is this? This is the predicted output. This is what I have shown and Ignite. Look at this. O1. This is O1. O1 is dependent on x11 multiplied by w plus what is the other inputs coming into this hidden layer? O dash, O0 into w dash. O0 into w dash. Like this, output for each network I have written for Shobha and Ignite. Okay. And finally, what is the summation of O1, O2, O3, O4 is final output yi. After passing through softmax function, you will get this yi. What is the loss? Yi is the predicted output, and we will subtract the predicted output with the actual output, you will get the loss. When you differentiate this loss, partially differentiate this loss with respect to the weights, with respect to the previous output, with respect to immediate previous output, then we will try to. So how when we are going to, when you want to update, when you want to look at the loss, first for feed forward direction, you will just calculate the loss. If you want, only if you want to reduce the loss, then only what I will do, then I will go in the backward direction. Then I will go in the backward direction. See, at the beginning I am just going in the forward direction. Okay. If you want to update the weights, then it will go like this, in the backward direction you will go. So in the backward direction, I will update the O4, I will update W, I will update W dash, I will update everything. I will start updating one by one, I will start updating. One by one, I will start updating. This updation happens during the back propagation. Updation happens in the, that is what I told you, back propagation. Loss I am going to update. Loss is yi minus y0 with respect to weight. Loss I am going to update with respect to output y, actual predicted output of our model. So if I loss is dependent on output y I had final output is dependent upon fourth layer, because I have considered 4 layers. Final output is dependent upon the fourth layer. Similarly, fourth layer output is dependent upon the weight that is getting in. So similarly, like this keeps on increasing. So by this, what you are going to calculate? What is this you are going to calculate? Look at this. You have the formula. W volt is equal to W volt minus dou L by dou W volt. Okay. So means what is getting updated here? Each time you differentiate the things, you deduct that with the older weight is, see, I have assumed W is equal to 0.5 and W1 and W dash is equal to 1. So now what is happening? I am differentiating. I deduct 0.5 minus dou L by dou volt. What is this 0.5 minus, what is this dou L by dou volt? This one. This whole term gets, this is 1. This term is equal to into what this is the minus W volt minus this whole term. Understood? W volt minus this chain reaction. Correct? Are you getting the things? So this happens only during back proper. So now it is a simple word. I love my India. Only 4 words are there. Simple document. This much huge text is there. Huge paragraphs are there. When it is too lengthy, what happens? What happens? There is a means, because each and every cycle. See, once you update. See, once you go here and once you come back to the initial point, forward propagation, backward propagation. Backward propagation, one set of weights is going to be updated during the backward. This is called as, how many is called as 1 epoch. This is called as 1 epoch. So what is my intention? I have to reach global minima. What I have to do? I have to reach global minima. So during each updation, if the weights, why I have to update the weight? If you update the weight, loss will reduce. And loss will reduce. Y I hat is almost equal to y. What is y? Actual output. Y I dash is predicted output. This happens. Okay. This should happen. Okay. If this is not going to happen, so it should come here. It should come here. Okay. But the RNN is going to work like this. But there are certain problems with RNN. Okay. So RNN is not the ultimate thing, but it doesn't mean that we don't use RNN. RNN is very important, but RNN has its own difficulty. Okay. So sometimes we encounter exploding gradient problems. What will we encounter? Exploding gradient. Already I told you what is exploding gradient in ANN also. Same way here also. See now what happens. So it is here. Next time it will go here. So it will somewhere fluctuate and it will settle at the global minima. But there is a lot of fluctuation happening. That are when the words fluctuations can happen when you want to upgrade the words. And there are, if this happens, usually happens when the tokens are what is that, terms, when the documents terms are less, the terms are less, it will explode. Because only 2-3 terms are there. You are changing the weight drastically, values will change, it will explode, and it will,
sir,
you will get confused.
If we go with a small amount of document, then the fluctuation will be
usually more. Fluctuation will be
with less document.
Yeah, if the document is too high, then it will slowly, it will never reach global minima. That is also, there is a problem. So such type of problem we call it as vanishing gradient problem. So we encounter vanishing gradient problem. We also encounter exploding gradient problem. So these problems usually we encounter in case of our recurrent neural network. But still, recurrent neural network is one of the most advanced neural network that we encounter. See, look at this. See here, same na. See here, if you see time step is equal to 1, input x1. I have given initializer
RNN also.
RNN only.
No, RNN also model like NL.
This is also it's a neural network. It's a deep learning model. RNN also a deep learning model. ANN also deep learning model. So used for text based application, for language translation, for creating the chatbot, for analyzing the sentiments. So for all this.
But for text we are using NLP, na?
NLP, yes.
Then what the
NLP is giving you only the numbers. It is not predicting this. Is it predicting anything? Is it predicting any output? Is it predicting? Yes, what you did in NLP last class?
Yeah.
Topic modeling you did. Only thing. You did only.
Output was not there.
Output was there. But it was not, what is that? It is not output that you have not quantified the output. Correct or not? So,
that output also
in
machine learning
you are giving some accuracy. In you are giving some ROCAOC, base ROCAOC value. In regression you are getting the exact value. But here you are not getting. You are just analyzing. You are guessing. In topic modeling you are guessing, na. But there was a number. There was a score. Based on that you are guessing. But you have to predict, na, whether you are going to purchase my product or not, based upon the comments. Based upon the comments, whether you are going to come and join at present or not. Most likely, whether you are likely to join or not, depends upon the comments given. Depends upon the word of mouth given by the previous students, by your seniors. Or depends upon the skill of the teacher. Depends upon how the things are there. Depends upon the market condition. If so many jobs are there, then also people are coming. So many things. But based on that, I have to predict whether you will join or not join. What you have to do? Either you have to go for machine learning. You are not interested in machine learning. You don't have confidence in machine learning. Support vector machine and what is that? Multinomial near batch. Only 2 models will work for text based. Other models you don't have trust. Why can't you try with RNN? We have RNN model. For doing the RNN model, we do all this text, not only here, machine learning if you want to do, then also you have to go through the same NLP process for text processing. All this lemmatization, stemming, stopwords, back of word model, that TF-IDF you have to go through, document to word model, that also you have to do. For applying deep learning model also you have to go through all this, because data pre-processing is common in whether it is a text or whether it is a number, that is a common. Understood the logic? Logic is same. Thought process is same. Techniques, different techniques we are deploying to get the output. Such that RNN is one such model for prediction. So look at this. You have that, say, input layer, hidden state, 0.5. So we have assumed 0.5 into, what is this? WH into H0. WX into, I have just told W into X. Here what they have assumed, WH. Here they have assumed hidden state. WH means W1 or W dash. That is what I told you, na? So they have assumed, for this they have assumed 1. Say 1 here. And for this simple W they have assumed as 0.5. They have assumed as 0.5, and initially dummy input is 0. 0.1. See, some assumptions they have made. See, hidden layer 1 will get the output. So the output from the hidden layer 1 will become the input to the hidden layer 2. So look at this. You got 1.1 here. This 1.1 I am using here. Hidden layer 2. Correct na? Similarly, you will get, so you will get, so 2.75, you will get 2.75. This 2.75 I am using here. Each, it's a sequential set of instructions. This is you just go and analyze. Same way it will work. Same way it is going to formalize same. And apart from that, I have forgotten to add bias. See, yes, added bias. What is bias? Noise factors. Unwanted errors. Purposefully, I will induce to make my RNN model more robust to unwanted, unseen data, unwanted inputs that will come. That also it should handle. So for that I am introducing bias. Bias will be. What is this alpha? What is this alpha? Alpha is activation. It represents the activation function. I already told. Each layer, not just multiplication, W1x1 plus W3x3 plus bias. This, after getting the output of this will be passed inside relay. It will be passed inside relay. It will be passed inside tan hyperbolic. Then the output will come. Then the output will come. Okay. So like this it happens, and it keeps on, and you get the output. During back propagation, you will get the, you will update the weight. I have told you how you are going to W old minus this one. Means each weights get updated. So looks like a process is complex, not so easy. Looks like process is complex, but it works. It is going to give wonderful results. You will enjoy if you work with RNN, RNN. But RNN has its own problem, that is exploding gradient problem and vanishing gradient. Sometimes it will never reach because so much big sentence, so many times you have to update the weights. Even if you update in one epoch, if you update the weights, small change in y you are going to output you are going to. Previous cycle, some output, for example 6.17. Now you see 6.172. What is the use? It will reach global minima. For that it will take 1000 epochs, 500 epochs. Who has time to sit till that? Sometimes it happens. Sometimes the process becomes because this is machine learning, no epochs. Where is the epochs?
No.
Direct one
That's
mathematical model is there. Directly you deploy numeric, you will get the output. One equation only, na? For a probabilistic value classification model, simple logistic regression, just one sigmoid function. Thus you will get the output. But here, so much of hidden layers, so much of updation, differentiation, chain rule, back propagation. That is why it is called as deep learning, complex process. It takes time, but accuracy levels are very high. But time consuming, more memory. All these things are there. Parallel processing you have to do. Without parallel processing, you should run IAM servers. Parallelly attached to that. You have to divide this into batches and then you have to make them to run. And then you will get we can make this to work quicker. Okay. So fine, just 2 minutes. Okay. So this is the this is about RNN. Okay. So next there is a problem, exploding gradient problem, vanishing gradient problem is there. So this problem we will have to overcome. So for overcoming this problem, we have most widely used LSTM, advanced neural network. LSTM we use BERT, we use transformers. I am not going to teach anything. We will only teach LS. All these are advanced models. That's up to you. You build on that. Gantt. Because each and every month new models are coming. I can't teach new models. Means BERT and all, it is there. It's similar. Once you work on LSTM, you can build. The logic is same. The architecture of the model you need to understand. Okay. Architecture of LSTM. What is this LSTM? Short term memory neural network. Long short term memory neural network. Like this, you have transformers, transformer model, bulk models, and so many models are
What is
there.
that?
But
BERT, BERT, GINT. So something like that it is.
GNT,
Huh?
sorry, GNT.
So like this, these models are there. We will discuss about LSTM tomorrow. Okay? Theory. After that, day after tomorrow, we will do one project. We will apply RNN. Also, we will apply LSTM. We will see the accuracy levels of both the models. Okay, and after that, you can do work on any project. We'll try. We check all NLP. First, basic thing is NLP. NLP pre-processing. How you have to do that? You should be knowing. Then we will deploy the model. So this will complete almost complete here, 90%, 90 to 92%. Then CNN 2-3 class, not more. Then I will give time. One project I will give, you do by yourself. It will take time for you to do. Means it you have to do. Otherwise you will lose this hold on the subject. You have to do. So that is what I think. I'll stop the recording. That's all for today. Thank you, Ignoil and